Let's go and begin the second portion of the information processing, and that is the response programming. So that is going to be the second area right here in the middle section of the reaction time. And this is where you have created or you've passed the stage of stimulus identification. And now it's time to go in and decide which response to generate, right? So this is where truly a lot of your experiences come into play in the idea of practice and identifying which direction you want to go according to whatever stimulus you've identified. Now this portion is really specific to the number of responses to a stimuli that you have available to you. And what we're going to look at this is a little research from Merkel in 1985. And the idea is this: if we look at on the x-axis, we have a number of select response alternatives. And so it goes, if you go from 1 all the way up to 10, and then you have the choice reaction time. You can see that it increases curvilinear as we increase the number of responses from 1 to 10. So in response to the selection, the number of choices we have available, it kind of continues to go up and from there. Now what we also know that is that as we do this, is a log base 2, right? So we've taken in log base 0 is 1. Here we have number 3, number 2. And then we go to 2, and so it's a log base 2, so it's 1, 2, 4, all the way going forward, right? What we now find is as we take the log base 2, it becomes a linear response. And the reason this is linear is truly because of that bump up from 1 to 2. If you look at from selection 1 to selection 2, so if we have 1 alternative to 2 response selections, it doubles our reaction time pretty much. So the idea is if we remove that really first big jump, then our response becomes linear, because essentially what you're doing is you're averaging every 2 to create your response. So if we do a log base 10, it becomes a linear response, but if we do it for every increase, it's curvilinear, and oftentimes it's because what we have here is we have this very big leap in the front, and at the back end, at some point it starts to slope and mellow out or plateau at the very top. And as you can see, if we look at this from 9 to 10, there's really not much difference in the reaction time. So at some point you become oversaturated and there's no more increase in time. Now, what this has to do with is this is the Hicks law, or the Hicks-Lehman law. And essentially it just talks about the choice reaction time will increase linear with a log base 2 component of it. And what you see here is this is essentially the choice reaction time equation. You have the A, which is the y-intercept, B, which is the slope, and then log base 10. And is going to be the number of choice selection responses. But it's important for you to note with this that we're talking about the Hicks law, or the Heyman-Hicks law. And these are just a couple of the experiments it's breaking from, right? So there's a more linear response when the number of responses is doubled. And so this is just walking you through it. If we double the number of selection response alternatives, the amount of information increases by 1 bit, and then the increased time required for choice reaction time is at a constant. And so just understand that the constant at which something is going to increase is the slope of the line of the Hicks equation, right? So as we create in each one of these dark black lines on these graphs, as now I'm making red, these are the slopes of the line, right? So you just basically, they're making a linear regression, and that's what this equation here. It's basically just a regression equation where the A, as we go forward, is simply the y-intercept, and it's basically if you had 1 alternative, this would be the choice reaction time. So when we start to do a lot of this, and we say, what is your reaction time to a certain response? We are simply talking about this log base 2 where n equals 0, or if you have 1 alternative, right? So this is basically the reaction time of the task. But then as we increase response selections or selection response alternatives, and we start to do it as a 1 unit or a log base 2, we can see that now we've created this log base or this regression equation, and it's represented in this by that B that you saw previously. And here you see the B, and so that is where you multiply by times the number of log base 2, and that'll give you the slope of the line. Now there are some limits of this Hicks equation, and a major one is the familiarity that you have to the responses of a particular stimulus. So the more you practice, the more you can anticipate, or the more that you can understand maybe a rhythm or a pattern in And so that happens with more practice or experience you have. And then also there's some known relationships between the stimuli and associated responses. And so there is this SR, or selection response ensemble, which is a set of possible responses available to you. And so we're going to get into a few of these kind of compatibilities, or the associations between the responses and the stimuli. And one is whether or not they are compatible, right? And so that's the relationship between this natural connection between the stimuli and the response. And think about this study here. So essentially what happens is you have two keys, and we'll say key 1 and key 2, and then you have light 1 and light 2. And so over here, it's 1, 1, and then you have here 2 and 2, right? So as we look at this, we'll say that this scenario A is much more compatible than scenario B, because if 1 lights up, then you touch key 1. If 2 light 2, then key 2, right? And so on scenario A, they're on the same side, right? So they're very compatible. If B, they're on the opposite side. And so that is one example of this compatibility portion. But then we also have this. If I have a coffee cup, and if you ever go to a restaurant, a fine dining restaurant, the coffee cups are always labeled are sitting on the right with the handle out to the right. And that's because most people are right-handed, and so when you grab the coffee cup, you grab it with the right hand. And so this is that compatibility. This individual is grabbing it with the right hand. You can see the hand, and this on the right. Now, if they're grabbing it with the right hand and they come around, that is more incompatible. So it takes them a little longer, and they have to organize a little bit more to grab that. So now we want to take it a little bit further, and this is the same scenario that we just had in the previous section, right? And so we're talking now about the idea that there is a benefit or an effect, not only of the spatial thing, but also whether or not the hands are crossed. And going down here, this is the A and B from the last section, right? So these stars, say these stars represent the light, and on each of the hands they have to represent which one goes in, or which one is supposed to be hit in reference to the line. So remember, we had in this one down here, this was 1, and this was 1, this was 2, and this was 2. So now we're going to do the same thing, right? And but the difference is now, if you look at C and D, the hands are crossed. And so in C, 1 and 1, 2 and 2, which is the same as A, which is 1, 2, 1, 2, except for now the hands are crossed. And so in D is the same as B, right? But what we can see over here on the graph is, here you have your reaction time, here's your compatible, incompatible. Incompatible is B and D, and then the dark is, so this is B, this is D, this is C, and this is A. And so you can see that having your hands uncrossed with the incompatible light of B gives you about the same response time as if your hands were crossed and the lights matched up. So the idea is that we have this spatial component which is greater than whether or not we have the response of our cross. So we see things on our left and right is able to respond much more rapid than if we go ahead and change our anatomical response, which is crossing our hands to the process. Going further, there is this idea is if you've taken biomechanics with me, or you've taken a physics class and talked about kinematics, you talked about position, velocity, acceleration, but you've also talked about force from a kinetic standpoint. And this idea intensity relationship is there is a compatibility with when force of response is mapped to a stimuli. Now, it is much easier to respond when you have a power grip than it is when you have to be nice and precise with the grip. And it's interesting. So what you have here is the power grip, just a big old grip wrapped around this bigger force transducer. And then up here, we have a much more precise grip where you have to squeeze a little bit and get exactly the small amount or precise amount of force generated. Where the bottom one, you're just trying to get as much or getting a nice magnitude of grip. And you can see they're very similar when you're at a small magnitude in both of them. The response time is very similar. But when you have to get a large magnitude or number magnitude or force component to it, the precision grip goes up drastically, and the other one drops drastically. Well, not really drastically, less than 10 milliseconds. but the bigger grip is much easier. And that has to do with probably a couple different components, but the idea that we're not really used to squeezing as much as we can with that finger to create it, and so we're not able to engage as many muscle fibers or motor units to do it. But also it's just a task that's much easier to do for us. It's more compatible. And then we have this idea of the Simon effect, and that's a spatial dimensions or irrelevance, where the auditory stimuli is deciding which response to use. And so the response is compatibility reduces to the right reaction time, and that's reducing the sports or the spatial orientation. So what we have here on this bottom in this graph is these are the ear presented with the message, and then you have a reaction time, right? And so the idea is if the ear is presented in the left versus the right, you are supposed to press the left key or press the right key, okay? So this circle here is you're supposed to press the left key, and if it's presented in the ear that you're supposed to press it with, the reaction time is much more reduced. And in both of these, it's about about 40 milliseconds of a reduction time if the ear you hear the term or this word in matches the hand you're supposed to press the key with. If you are instructed to do this idea or this task and I'm told in my right ear to press my left, I increase the reaction time. So this again is called the Simon effect, and it's more of a kind of an auditory stimuli, so it doesn't really matter what the spatials, depending on what ear you hear it in. So response selection stage is affected by these compatibility effects, and the effect is magnified as you have this highly learned association where left and left, right and right, or right and right, and where spatial things are with how we want to grab things or just our environment in general. And this all can be affected by the more we practice. So if you are somebody who practices in one way all the time, then you're much more likely to be able to perform that task in that way at much more rapid than the other because it becomes more compatible to your environment.